Oh, thank you. So I want to welcome everybody tonight to our second night of the Sustainable Ramona Water Conservation Series. It's the first of a series of presentations that we're doing to offer resource suggestions to improve sustainability in Ramona. Our next presentations are tentatively scheduled for the second week in November, and we will focus on ways to make houses and businesses sustainable. And we'll look at getting rid of gas to convert to electricity in order to use saving devices such as heat pumps and solar energy. And we'll look at a way to evaluate solar systems and perhaps battery backups as well. So you can get details for this at the Sustainable Building Symposium later on. We also have a Facebook page. Sustainable Ramona has a web page, and we also will hopefully be recording all these video presentations and be putting on Sustainable Ramona's YouTube page. What I'd like to do is welcome tonight Jim Hickel. He is the president of the Ramona Municipal Water District Water Board. He's served on that board for 7 years. He is also the chairman of the San Diego State University Mechanical Engineering Department's Advisory Board. And he is also the Operational Excellence Advisor for Caterpillar's Energy and Transportation Division. He's a busy guy, and so we're grateful for his time. I also want to just say thank you for the current board's message to the community that you're here to be servants of the ratepayers and that you're doing that tonight by being our guest speaker. So I welcome Jim Hickel.
Well, thank you very much. It's a pleasure to be here. I'm looking forward to sharing a little bit about the water district and also talk a little bit about safe, sustainable, reclaimed water. Let me see if I can get this to go forward. Go forward. There we go. So a little bit on the agenda, we're going to go through an intro to the Ramona Municipal Water District, give you a little bit of information about the water district that serves Ramona. We're going to talk a little bit about water services and provide an overview of that. And we'll discuss some of the current water sources for Ramona and what are some potential water sources for the future. Then we're going to switch over to the downside of the water, and that's the sewer services. Give an overview of sewer services that we have here in Ramona and the water reclamation, as well as we'll discuss recycled water, a very valuable resource in sustainability. And it's what we currently produce, and then what is the present and the future of recycled water as we see it. So a little bit about Ramona Municipal Water District. It's about 75 square miles, 45,800 acres. We have about right around 7,000 parcels. 3,000 of those are rural, out in the backcountry, and much more acreage to serve. About 40,000 people. We have both potable and non-potable water. We are in the process, though, of decommissioning the non-potable system. The reason there is that there's just not enough volume anymore to keep that system completely viable and cost-effective for the ratepayers. We have both sewer and recycled water. We'll go into that. We also serve the Ramona community with fire protection. We're responsible for fire protection. We have 3 fire stations, as well as, and each one of those fire stations has a fire engine, and they are now staffed with advanced life support paramedics. So each engine is staffed with a paramedic, as well as we have 2 ambulances that accompany them, and they're also staffed with a ALS paramedic in the ambulances. And we have one ambulance on standby. We also look at and we work with the Ramona Community Parks Association and at Wellfield Park. So the water district owns the land around the fairgrounds, the softball fields, adult softball fields, pony fields, all through that Wellfield Park area. But the management of that is left to the individual organizations through the RPRA. Here's a map of the RMWD service area, so you kind of get a scale of how far it is. On the right-hand side, you see the country estates. You go out all the way on the left-hand side. We go all the way down almost to Rancho Bernardo and out through the west end. Oh, shoot, I've forgotten the highway name, but all the way out through the west end, almost down to Rancho Bernardo. That's mostly where we have our untreated system. You see the green tanks there. That serves a lot of avocado growers. And then you see a lot of these, the blue tanks are all treated water, and the green tanks are the untreated water. At the district for the budget year of 2021-22, there are 49 authorized positions. We just increased to add one more position to the water district in our water sewer operations. So now that all of your water, sewer, administrative, finance, the accounting systems, the IT systems, all of that is encompassed with 49 folks that work for RMWD. The fire have their own contract that's contracted with the fire chief with CAL FIRE, and those they have, that's not counted in those 49 positions. So as well as the engineering is contracted with a company called Dudek. So we have one engineering technician that actually works for Dudek, and engineering technician that actually is a district employee. So this is some of our current budgeted capital investments. We put together a capital investment plan as a board with staff in the district each year. We assess those priorities with the leadership team that are responsible for the facilities and determine which things we want to pay for to in the future. I'm not going to go through every one of these. You can kind of read through this list, but one thing I wanted to highlight is that it's a pay-go system. So we don't finance the projects like you would buy a new car. You would finance that car. You buy your home, you finance that home. At the district, at Ramona Water District, we save our money ahead of time so that we don't have to pay finance charges, or the community does not have to pay finance charges on any of these capital investments. All these are paid for upfront with money saved and from the ratepayers, and so that helps us so we don't get beyond our means, and we save some percentage on interest, which at some of the costs of these can be quite significant. There's a continuation on our capital investments. One of the things I want to highlight here is in our water facility master plan. We just finished that. We do that every 5 years. And inside that master plan, it is a plan for the recycled water. One of the other things as far as sustainability I would like to highlight here is our natural gas engine. So in the past fires, when the power went out, our ability to pump water went out in our last major fire. And that created a big issue with actually replenishing or pumping water up the hill. As you'll hear from me, all the water that we use comes up from Poway through the County Water Authority, San Diego County Water Authority. So if we don't have the electricity on, then we don't have the ability for the pumps to turn. So as a result of that, we're now putting in our second natural gas engine and pump, so that in the natural gas, it doesn't get shut off like the power would in a fire or in a high wind event. So that enables us to continue to pump water up the hill in the event of a fire, or just in the event that the electricity goes down for whatever reason. And that was a great capital project. The neat thing about that is natural gas has been a lot less expensive for us to pump water with, and so as a result, we actually were able to reduce our pumping charges by using natural gas instead of electricity. Okay, I'm going to get more specific now and move over to water operations. First and foremost is our priority is to ensure a safe and sustainable water supply for Ramona every day. We don't take a day off. The water district never takes a day off. They're working there every day and to try to ensure we have a safe and sustainable water supply. And this is something in my job, I travel all over the world. I've been to, well over 50 countries. And I one thing I always reflect back on as I travel is, and I'm very thankful for, is the fact that we can drink the tap water coming right out of our faucets at home, and we don't have to worry about that. It's safe, it's drinkable. We don't have any concerns with that. That is certainly not the case as you travel around the world, and I really appreciate that. I appreciate that as an engineer. I appreciate that as a consumer, as a father, and as a community member. It's really important that we keep our water safe. Our water system service. Just some details here. In the distribution system, we have 12 pump stations, 21 storage tanks. You saw those in the map. We have a total system capacity to store 25.3 million gallons of water. We currently use about, it depends on summer or winter, you see at the bottom of this slide, 2.5 to 3 million gallons in the winter and 4.5 to 5 in the summer. So if we were to average that to 4, we have about 6 days worth of water stored in our storage tanks if they're at capacity, and that's 25.36 million gallons. Lake Ramona is, and many people don't know about Lake Ramona. Yes, the water district does have a lake. It is on the west end, and it does have a significant amount of storage, significantly bigger than some of the more small lakes like Poway Lake and other smaller lakes. It has a storage capacity of 391 million gallons of water over almost 12,000 acre feet. They have a SCADA system. A SCADA system is essentially radio controlled, so you don't have to have a wired system for some of the valves that are turning on and off in our water system. One of the key ingredients of our service is to respond to customer requests. We are very much in this board, or particularly very focused on serving the customer and responding to customer requests to make sure that that's both timely and that we consider the water district as working for the customers and helping them be successful. And so that's something that's real important to this board, and so we get a lot of requests or a lot of issues reported on a daily basis about the quality or the taste or the odor or potentially the color of water coming out of the spigot. And so we address those high and low pressures as well as no water. So every day there's something going on with respect to customer services, and we realize and serve that. As I said earlier, our annual demands are somewhere, I'd say, between, let's say, 3 million gallons per day, 3 million gallons per day, or 4 million in the summertime, like we have today, a very hot day. It will spike up to 5.8 or 5 over 5. In general, water usage has been steadily declining over the years as a result of conservation, and so I think the water consumption that we had 10 years ago is quite a bit larger than what we have now. I didn't include any slides on that, but it has diminished, I guess, around anywhere from 20 to 30%. Our assets, we have in the district, there are 9,800 meter connections, about 220 miles of pipe. So you think about that and how far you can go, 220 miles of pipe, anywhere from 4 to 30 inches. A significant amount of those pipes, over 50 miles, are 50 years plus, or well beyond their design life. And so we have a lot of deferred maintenance. In Ramona, we have about 11 breaks a year of these old pipes that we have to fix on an emergency basis. And it's always more expensive to fix those when it's an emergency. There are 4,500 valves, 1,500 fire hydrants, and blow-off valves as well, air valves. Many times blow-off valves are necessary for taking the air. We don't like compressible fluids inside our pipes that causes problems, or air in the lines, so we have blow-off and air valves. As we say, the tanks, there's 16 of those tanks are potable water, and then 5 of those are non-potable water, which you talked about the lake. And then water pump stations. People don't realize, I think, that it's not just pump it up to the top of the hill and stop. There are 12 water pump stations around the district to keep the water pressure up. And both those are natural gas and electric driven. And you see the term here used, acre feet. And just so you understand, an acre foot is 325,851 gallons of water. That's 1 acre, 1 foot deep of water. We also have a laboratory division in water operations that supports both water and sewer. It's a state certified lab. And it's testing and testing and testing every day. We test every day the water quality, multiple locations. There are many regulations about stipulations for what makes clean water and suitable water, and we test for that every single day. We're certified to perform these tests as you listed below, and those are done either for the water system or for the wastewater system for recycled water. There are many stringent requirements on the wastewater as well. It's not just as simple as, take out the solids. You have to treat the water, the wastewater as well, to a certain standard. Where do we get our water? We get our water from a Twin Oaks Valley water treatment plant. The majority of the water that we get from the San Diego County Water Authority. We purchase 100% of our potable water from the San Diego County Water Authority, and we pump it up from Poway. So it's roughly about a 1,300 foot pump. So, you kind of get an idea when you're pumping millions of gallons of water, the electricity usage is pretty high. All those things considered, I want to bring your attention to what is the actual water cost to Ramona customers. So for a gallon of water, and I want you to think of the gallon of water that you buy at the supermarket, and what that costs you at 99 cents a gallon if it's on sale, or $1.50 or $3, whatever you're paying for a gallon of water. A gallon of water to you at your home costs less than 1 penny coming from the water district. It's 0.008 cents per gallon, or $606.56 per unit, which is a unit of water is 748 gallons. We do have a 98 cents per unit charge to pump it up the hill. So that's called the pumping charge. You see that on your bill. So on your bill, you're charged by units consumed, and then by pumping charges are for the electricity to pump it up the hill, and that's by units as well. But it surprises people when I share with them how inexpensive 1 gallon of clean, potable water is coming out of their faucet. It's a pretty good deal. So where does the San Diego County Water Authority get their water? What are their water sources, past, present, and future? And I want to spend some time on this because I think it's important for us Ramonans to consider. Back in 1991, 95% of the water that came into San Diego County was coming through the Metropolitan Water District. So they were very one-sided. I would call it sole-sourced, with only a small piece of that pie being local surface water. Fast forward 20 years, 30 years to today, 2020, or last year, 2020, and you see the diversion where now the San Diego County Water Authority has diversified our water supply. Now, why is this important? Well, when you think about all of the counties in the state, If we were relying on just water coming from Northern California through the Metropolitan Water District, we would also be considered in the drought. San Diego County Water Authority has done a very good job, in my opinion, to diversify the water supply and over the years. So you see we have a contract where 31% of our water comes from Imperial Valley. Then you have the All-American Canal of Coachella, and then seawater desalination is 8%. And then local surface water still plays a role in that. Some of that is recycled water. But more importantly, what I want to draw your attention to when we talk about sustainability of water is the 2045 vision. Essentially, in the 2045 vision, you're looking at the difference there is 18%, and that 18% is from 0% today to 18% of the water for San Diego, what's called direct potable water or indirect potable water, and we'll go into what that means for the future as well. But there's a lot of projects, and this is the latest move in the water business about how do you take your recycled water and move that to potable water. And there's a lot of ways to do that, and we'll go through some of them. Okay. Now the question for us in Ramona is, we are sole sourced. 100% of our water comes from the San Diego County Water Authority. Does it behoove us to diversify some of our water? And that's an important question. And so when you think about diversification, there's a lot of reasons you would want to diversify your water source. Same reason why the San Diego County Water did. You never know which source can go dry. I think San Diego County Water Authority does a very good job. I think it's been a great relationship. So when I talk about, when I think about diversification, I want you to think about potential future water supply options for Ramona. I got a spelling error there, sorry. For Ramona. Well, one of those options is just to continue to sole source water from San Diego County Water Authority. They're already diversified, as you saw on the pie chart. They are reliable. They are supplying water to all of San Diego County. They have a significant amount of storage capabilities. And as I've shown, that they're relatively cost effective. I think if we were to try to produce the water, it would be almost a push if we tried to do our own water, buying raw water from them and then treating it. It would be very close to the same cost. We do have an option to augment San Diego County water supplies with our local groundwater. Now, when you take water out of local groundwater, meaning the well, and we do have wells at the district. They're mostly through the center of the recreation grounds. All of the well-filled park, the ball fields, all of that is irrigated with well water that comes up from the aquifer in Ramona. But you do have to be cognizant that you have to recharge the aquifer. This is one of the big issues in Northern California, that aquifers have not been recharged. They haven't focused on continuously recharging the aquifers, just taking deposits out of the aquifer and not putting anything back. So now there's a lot of effort to put down, and that's where you get things of, well, your aquifer is now stressed, and that's where you get things where people are putting meters on their wells, wanting to know how much water they take out, how much we have to put back in. But one way is to recharge your aquifer is with a system called indirect potable reuse. And that's where water districts are taking their sewer water or their recycled water that comes from the sewage treatment plant, and they're putting it into percolation ponds, or they're putting it into injection wells. And this strategy is now widely used in Southern California for many of the water districts to mix water. You'll also see that they're doing indirect potable reuse in pumping it directly into the lakes. So you'll see a couple projects I'll go over when I talk about recycled water with the San Diego and with Padre Dam and Helix Water District. We could revisit the purchase and treatment of local runoff storage from the City of San Diego. City of San Diego does own Lake Sutherland. Back in the day when we had the Barger water treatment plant, we used to purchase our water from San Diego City and treat it and then pump it into the treated water system for Ramona. We have abandoned that strategy, and now again, 100% comes from Poway. One of the nice things about that strategy is as electricity becomes more and more expensive, we don't have the cost of bringing it up the hill. It's already above Ramona, so you get the benefits of all of that elevation in utilizing the water from Lake Sutherland. The other option in the long term for water districts is to think about direct potable reuse. You know, many people, there's lots of names that people called this before, you know, toilets a tap or whatever it might be. This is the new name. It's direct potable reuse. And this, if you just look at our effluent flows through our district and how much recycled water we have available, this could be upwards of 25% of our total demand in the event that the technology and the cost of that technology comes down to where direct potable reuse is widely accepted, as well as accepted in the community. Because, you know, let's face it, there's a perception of drinking water that used to be sewer water. So we have to overcome that as well, and some of those perceptions are changing. So now I'm going to skip over to wastewater. Before I do I have any questions or anything on the water side? Okay. I'm going to move over to the wastewater division. Wastewater is our sewer reclamation plants. We have two of them in Ramona. One of them is San Vicente Water Reclamation. It's permitted for 800,000 gallons a day. We typically process out there 500,000 gallons a day. They use secondary and tertiary treatment processes, which includes reverse osmosis. This reverse osmosis plant that's in San Vicente was way ahead of its time when it was put in. Not very many plants have that. Not a lot of water treatment plants, sewage treatment plants still have reverse osmosis. It's a very nice system to have. It gets very clean, gets the water very clean, removes solids. It's essentially the same reverse osmosis you have in your house. It's just a lot bigger. Currently we have San Vicente. We have one recycled water customer. That's San Vicente Golf Course. They take about 300 acre feet a year. And so think about that. 1 acre foot is 325,000 gallons, and they take 300 of those every year to water the golf course. It's a great asset for the community, and it's a great partner. They purchase the water. It's not free. It is a revenue source that comes back to the ratepayers as part of the water offset of water operations costs. And we also have one active effluent spray field. That spray field is up at what we'd call the Spangler Peak Ranch, up above the the San Vicente reclamation plant. It's currently able to take about 150 acre feet a year between the two. And we have some other options as well, but between those, we were able to cover the amount of effluent that we need to discharge from San Vicente. All of the reclamation plant is run with 3 certified operators. They are on call 24/7. So, they can't leave town when they're on call the weekend. So every other weekend, someone's on call. And so it's a great group. They do a lot with just a few amount of people working. Great team. Over on the other side of town, we have the Santa Maria Water Reclamation Plant. That is actually fairly close to the airport. It's permitted for 1 million gallons a day. We typically produce about 640. Same processes, secondary activated sludge, but we don't have a reverse osmosis plant over in the Santa Maria water basin, or that water basin, that aquifer, it's not required to have the reverse to remove all of the total dissolved salts and solids that are inside the water in that Santa Maria water basin, as it is in the Gower Basin over on San Vicente. So we don't have to have an RO system in Santa Maria. We do have one recycled water customer currently, and that's the Mount Woodson Golf Course. They take around about 180 acre feet a year for Mount Woodson. They have a ability to take tertiary water. They have their own plants to take our secondary water and make it tertiary that they paid for. It's over off Rangeland, and it's can do 350,000 gallons for a day, or 1 acre foot a day roughly. We have, for the rest of the water, because you see we can only do 350, and we produce 640,000 gallons a day out of that water, that sewer plant. The rest of that water that the golf course is not using, and even when it's raining and such, the golf course doesn't need to consume recycled water. We have spray fields off of Rangeland Road as well, and those spray fields, if you walk out there, hike out in the preserve, or you can see them, and it's just nice green grass. And we have there's some cattle that we contract with that eat the grass, and that's where the spray field takes the rest of the effluent on a daily basis. Santa Maria is a little bigger, a little more spread out, and there are 4 certified operators there, but again, 24/7 on call. I want to spend a little bit of time talking about the reclaimed water. Just some reclaimed water facts that I think it's something that we should think through as we think about sustainable water and the future. Up in starting in the top left here, Perth, Australia, they 20% of their drinking water comes from reclaimed sources. So that's a huge number. You look at San Diego City Council recently voted unanimously to spend $2.5 billion to recycle wastewater. Orange County is recycling wastewater for 2 to 4 million people. They're doing 70 million gallons to 100 million gallons a day. And you look in the middle of this slide, and you look at 95% of all the water entering our homes goes down the drain. So that's going right into the sewer, 95%. So there's an opportunity for us. And you look at the bottom, and we think about desalination and how important that is, but the cost to recycle water is 35% less than desalination of ocean water. So there's a great resource what we have right in our community, and that is the wastewater that's coming out of the waste treatment plants, for us to use. A lot of other benefits of recycled water. You think about earthquake and the preparedness. If we had a major earthquake, all these pipes that are providing us with water, they're all in the ground. They're all coming down the state. They provide San Diego County with their water, lots of big, 6 foot across, 12 foot across pipes that are susceptible to break in the event of a major earthquake. So water supplies can be interrupted through earthquakes. And so when you have local water supplies, you have a backup. Currently, we don't have a backup other than the 6 days of storage that Ramona has. Drought, when you produce, you have a drought-proof source of water. If you're using the water that's already here, that's not predicated on how much rain you get. So you're already using it, you're reusing it, and you're reusing it again and reusing it again. And so it is a drought-proof solution. Recycled water does replenish groundwater basins. That's a very easy use of it. We can do that very easily in Ramona. It's also, it's economical. And it uses our wastewater, it puts it to good use, uses the regions. It's our largest untapped source of water. I don't know if you know this, but all of San Diego counties, the majority, if not right now, currently, all of San Diego County's water that's consumed in the entire county that goes into the sewer just gets treated out of Point Loma or up north in Carlsbad and just gets pumped out into the ocean. So we pay for this water, we pump it out, we use it in our gray water systems and our black water systems, and then we clarify it, and then we just dump it out into the ocean. We don't reuse it at all. We wait for the evaporation and rain to come. So it's definitely one of our largest untapped surface opportunities. Recycled water. There's two kinds of paths for recycled water. Comes from your home, it goes into the waste treatment plant, then it goes to the left. And this is what we would think of if we put on our hat today and said, this is the traditional recycled water part. We would take wastewater treatment. We'd have Title 282 water that's not drinkable, it's non-potable. You can't contact any fruits or vegetables without water, but it can water agriculture, it can water landscape, and it can water industrial. These are the typical purple pipe type water that you see for reclaimed water. Now let's take a look at the right-hand side of this, and we say there's an advanced purification facility. And this becomes purified water. It goes through more rigorous filtration, through reverse osmosis, through some ozone treatment, through some micro filtration. And literally in some cases, it's coming out as pure water. It's so pure, it won't conduct electricity. And that's actually how you measure how pure water is by how conductive it is. And so the water comes out of these purified, pure treatment systems. They actually have to put the minerals back in the water, and then they put it in either to the groundwater as indirect potable reuse or into a reservoir. And both of those paths you see right there, whether you do it in a reservoir or groundwater, that's called indirect potable reuse. And then it would go through the normal drinking water treatment and then into your home. In Ramona, in total, our sewer reclamation plants have approximately 500 acre-feet of recycled water available to offset purchase water, or about 13% of our purchase water. That's not including what the golf courses currently. So incremental to what the golf courses are currently using our current customers, so they're not harmed. They don't take away water from them, but we still have 500 acre-feet of recycled water that we can currently offset purchased water with. So that's a valuable resource, and we want, one of our objectives in the water in this board as well as with staff in the future is to start strategizing how are we going to use more of our recycled water and keep it in the valley. So public perception. We chat about this. We don't want to ignore this because it is an important aspect as we think about where we're spending our rate, what our ratepayers are spending money for, with paying for all these capital improvements and such. But I think 50 out of 58 counties in California are in extreme drought. There's a lot of folks, and they surveyed 3,000 participants in California, and 76% feel that recycled water should be used. 87% support recycled water as an additional source of water. And 83% are willing to use recycled water in their everyday lives. So some of the perceptions of, toilet to tap and such are changing. And this is an important aspect as well. And water reuse, and what you're doing here with sustainable water in this lecture series is very important to changing the people's perception of how water could be used. As I mentioned before, but I'll go into a little more detail here, there are trends in recycling water that are different than that traditional use. But two of those trends are indirect potable reuse, and that's where the water comes from your home. On the left-hand side, goes into the water treatment plant, goes into a pond or reservoir or a spray field, gets put into the aquifer or drained into the aquifer, or it just stays in the lake. In this case, in San Diego City's case, they're going to be putting water directly into Lake Miramar and into Lake San Vicente. Then the water is taken out of the lake. There's like a 25%, you can't be more than 25% of the total volume of the lake. And then that water goes into a normal water treatment plant and then goes back into the house, and that's the cycle. So that's indirects. And the indirect piece is really, it goes into an environmental hold. So somewhere in the environment, either in an aquifer or in the lake, somewhere it gets held in the environment for a certain amount of time. That's what makes it indirect. Direct potable reuse doesn't have that environmental element to it. It comes out of the home, goes into the sewage treatment plant, comes out of the sewage treatment plant and the advanced filtration systems as pure water, and then will go into a water treatment plant. In those water treatment plants, instead of making pure water out of it or cleaner water, it's as clean as water is going to get coming out of the water treatment. Then they do have to put minerals back into it. So they have a lime treatment process and some other mineralization that comes in, and it gets mixed with the other potable water and then gets delivered to the customer. And that's direct potable reuse. There's not a lot of places in the United States that are direct potable at this stage, but indirect potable is probably the preferred method at this stage of the game for water districts. Speaking of water districts, here in this chart, you see a lot of indirect potable reuse and direct potable reuse projects that are underway. Two of those I want to draw to your attention are the local IPR projects. San Diego City, they're doing a pure water project. This is $2.5 billion. It was delayed due to some court action, but they just passed the last hurdle. They have all the permits. They're starting their construction later in the first part of next year, and they hope to be finished by 2025 and ready to treat millions of gallons a day. That millions of gallons of treated water or recycled water through advanced filtration will go into Lake Miramar and into the San Vicente. Recently, you may have seen an article in the paper that Padre, which is Santee, Lakeside, El Cajon, and Helix Water Districts, also Lakeside, El Cajon, they have just received a $288 million loan from the EPA to do the exact same thing that San Diego City is doing, and that is to build an advanced filtration system to take their sewage and start injecting that advanced treated water back into Lake Jennings. And they expect to get about 25% of their water, their currently purchased water, and offset their water by 25%. Two great projects. All right. In summary, all of RMWD's or Ramona's water potable is imported. It's safe and sustainable is our first priority. And the big question is, should we diversify? Should we have an alternate source? It's an interesting question. There are pros and cons to both sides of that argument. Public acceptance of the water, recycled water has grown. We've seen a difference as we become more and more cognizant and we continue to grow in the public of climate change and all the things that are coming around with drastic droughts and water cycles are becoming shorter, drought cycles are becoming shorter. Public acceptance of recycled water is growing, and not just the public. I would also say the regulatory environment. We're seeing a lot of regulatory change, or at least an attitude of regulatory change within some of the county and the state water authorities. While Ramona does use recycled water for its 2 golf courses and there's some small agricultural use still, there is still 500 acre-feet a year to offset purchase water. It's an opportunity that we feel is worth exploring to maintain the sustainability of keeping the water in the valley. Indirect potable reuse is becoming a mainstream recycled water solution for arid areas in the U.S., including San Diego. And so this indirect potable reuse is certainly something we have to explore. as we look at how do we diversify or make our water more economical or even just more reliable as a secondary source. That's all I had for the presentation on recycled water and RMWD. I open it up for any questions.
So
Yeah, I got one. It's Bob Maycomber here. I live over on the west end of town near Lake Ramona. And I wondered what is the purpose of Lake Ramona, and could some of this recycled water be stored in there as opposed to squirting it out into the fields?
Bob, excellent question. Yes, the answer is yes. The original purpose of Lake Ramona was for us to buy raw water from the San Diego County Water Authority and then to have our own treatment plant on the west end and then supply the treated water to Ramona that way instead of the barger solution where we saw the writing on the wall. There wasn't always going to be local water coming into Sutherland. So we decided to create a lake so that we could store water for a sustainable supply of water in Ramona. However, they found a better and more economical solution, and that was to just build a pipeline to the from Poway to the treated water pipeline from the San Diego County Water Authority, given that they expanded their water treatment plant. And so now, and this lake really became something somewhat of an anchor. We fill it with water, it evaporates, and some people use it for recreation, but it's not very useful at this time. And we make jokes about it. If anybody wants to buy it, it's for sale. But I think with indirect potable reuse, as I explained in the presentation, we're finding that investment in Lake Ramona may not have been a bad idea, that there is an opportunity for us to utilize that lake to inject recycled water into the lake and use it in the same way that Padre Dam is, Helix Water District is, and the city of San Diego, and many others throughout the state. They're using these small reservoirs as their storage centers for indirect potable reuse. And that could be an option for us, and maybe even Poway to consider. So we're kicking that around and seeing if those concepts fly, and we'll go from there. But that's a great question.
Is Lake Ramona very deep? Is there a high ratio of evaporation?
It was. We recently made a decision to lower the level of the lake so that we could reduce the evaporation in half. So we've done that, or we're doing that. I don't think of it as a very deep lake. I think if memory serves me, I think right now it's about 50 feet. It's not very deep like you would think of San Vicente or some of the others that are El Capitan. Some of them are deeper, but right now it's not. But it does have a large capacity when you compare it to other lakes like Poway or Miramar, Lake Murray. It's got a significant capacity, especially enough for Ramona.
I don't see any questions in the chat, so feel free to do what Bob did, is unmute yourselves and ask the questions directly. And Jim, thank you for explaining the difference between indirect and direct potable reuse. It clicked for me when you showed the slides and you explained it. I didn't get it before, so thank you.
Yeah.
I've got another question, Jim, if someone else doesn't. I also live right next to the spray fields here on the west end, and that water is largely replenishing the groundwater.
Yeah, it's when you spray, it does have a trickle effect to replenishing groundwater. It's not the preferred method to replenish groundwater because most of it evaporates and is held onto the grass. The grass picks it up pretty quick. Most groundwater replenishment is done through percolation wells or percolation ponds and injection wells, where they can actually get the water down into the aquifer a lot more efficiently.
So I mean, that's better than dumping it into the sewer and down into the ocean. But
Yeah,
why not somehow get it better into the groundwater system?
that's exactly the question, is if we were to do the indirect potable reuse, I mean, it does trickle into the groundwater, the groundwater in that aquifer and the Santa Maria aquifer or the Santa Maria Basin is quite well. I mean, everybody that I've talked to, their wells are very well, good producers, and it's good quality water. But it's, if we did do the indirect potable reuse, we would likely go to an alternate solution where we are having some percolation ponds or something that would be better for getting it into the aquifer. That particular aquifer right now is not suffering from any, it's what we would call a very low priority aquifer relative to the California. That's how they judge it, because it has such a high level. And there actually are very few, the only medium priority one that requires an aquifer sustainability plan is one down in San Pasqual. Um, they are the only aquifer that's of medium priority. Everyone else is low or very low in San Diego County.
So there's two ponds there now, Jim, that I guess the spray fields feed from. Why
Correct.
not turn those ponds into that interim function in the cycle that you showed?
Yeah, that would be it would be, I don't know if it'd be those exact ponds. You're looking for the geology to percolate down, so it may be much more of a sandy soil type bottom. But I don't know if those exact ponds would work. It would take a geologist to figure out where's the best place for us to replenish an aquifer with a percolation pond. But the concept is very true. They're a little bigger than that, some of them that I've seen, but those size ponds are, and a series of them do work.
Thank
Can you
you.
explain a little bit more about the priority of the Santa Maria water basin for the people that have wells? Because you explained there's the low, the medium high, and the high priorities 1 through 5, and how we're not in the highest priority. So some people are worried about their wells being, regulated or all that
Yeah,
sort of stuff. So if you can address that.
when you in Northern California there, and even as much as Temecula, you look at Temecula is served with their water. Significant amount of well water comes out, or water comes from groundwater in Temecula. And so when you have these aquifer basins, the state of California goes through and identifies the priority of the sustainability of that aquifer or that water basin. So they do a ranking of each water basin depending on the size, the geology, the amount of water that's in it, and then also if there's people pulling water out of it. So they rank these water basins as a very low, medium, high, or very high priority as to it having a sustainability plan, meaning that you need to have what it would call, I forget the acronym, but it's essentially a plan that a committee or a board looks at the aquifer in the area and says, oh, how are we going to create a sustainability plan for this aquifer? When it's medium or above, then you're required by state law to have this board formed. It's like like a water board, but its sole purpose is to look at sustainability of the aquifer. And then they're required to put together an aquifer sustainability plan and submit that plan with the state. Many times that plan includes understanding how much water comes out of the ground or out of the aquifer. And so that leads a lot of these aquifer sustainability boards to mandate that a meter be put on the board or on your well. So they know how much water is coming out. Not that they're charging you for your water or they're just looking for data on how much water is coming out of your well versus how much is they have to put back in. In some cases, there are limits put on how much water you're allowed to in severe drought, and there's some triggers for that. But for the most part, that's why you see meters on wells. And again, that would happen only in a medium or a high or very high priority water basin. Santa Maria and the Gower Basin over on San Vicente side, both of those are very low priorities. And so we're not required to do anything in Ramona regarding those basins. Now, should we choose to take water out of those basins, that could change, and we'd have to be very cognizant of whether or not. Now, again, it's a board. The board's elected by the people, and that they would represent the people of Ramona, this aquifer sustainability board, in the event that we ever needed it. But right now, we're not even on their radar. Does that explain it, Beth?
It does. It does.
I have a question. If am I unmuted, I think? This is
You are.
Donna. Oh, okay. I just wanted to revisit Sutherland Dam, since we're out on the east end, the current use for it, and what's the future since it is so low. Is it continually being drawn upon, or?
Well, Sutherland Dam is like the Lake Sutherland, like any lake, is a minimum level that it's allowed, that it has to remain at for environmental reasons. So the San Diego City knows what that level is, and they can keep it above, or they have to keep it above, but how full they keep it is completely up to them. The reason for Sutherland Dam was put in just to capture local runoff. There's no pipeline that feeds into Sutherland Dam. It's 100% local runoff. I mean, it would have been great if the forefathers of Ramona would have realized that and put Lake Ramona up there where Lake Sutherland is, because that would have been perfect if we were able to capture the rainwater from that basin. But the city of San Diego beat us to it, and they own Lake Sutherland. They put in the dam. They spent the money with back in the day, and what they do with the water essentially is, when it gets full from rainwater, they open the valve and they drain it into San Vicente. Right behind the Van Tol's Dairy is a pipe that pops out and flows water directly into the creek, and that creek goes down into the Sutherland arm of San Vicente. And then San Vicente is where the city of San Diego pulls their potable water for their water treatment plant for the city.
Okay.
As well as
friends of ours, so we've gotten to see that valve and that pipe.
That's how Sutherland functions, and to my knowledge, I mean, it is quite low. I haven't seen it recently, but I think all the lakes are quite low.
Mm-hmm. Yes. Well, thanks.
All right. Any other questions?
I could throw out one more, being on the east end, when you were talking about the water table levels. Since we're all on well out here, how do you find that information out? Is there something with the state?
The best thing for you to do is to measure your own water level. Usually it's done with just a drop down, and you see when the string is wet or something of that nature. But there are, on the west end of Ramona, where there are in that whole field where the spray field is, there are observation wells in which they are taking water samples from the observation wells, and they also are measuring the depth of the water. And the county has a department that keeps track of all that data. I don't know if I've not seen a report on the east end of Ramona, so I'm not sure if there's the same there, Dawn, as there is on the west end.
Okay. Thanks
Yeah.
again.
Well, I hope everybody learned something today, and you know, as we go forward in the water district to become more sustainable, that you'll continue to give us your support and talk to your neighbors about the importance of us, you know, being better stewards of water and sustainability of the water, the recycled water that we do have, rather than just spraying it on the ground. And thank you
Amen to
very
that.
much.
Thank you so much. I appreciate your time. I know you're very busy, and I just learned a lot. Even though I've studied a lot of this, there's still more to learn all the time. So I'm sure everybody else has learned so much tonight, and I thank you for that, Jim. Your time's valuable, and we appreciate that.
It was my
Yeah,
pleasure.
We do appreciate your taking the time with us, Jim. Thank you.
Yeah, thank you.
You're absolutely welcome. It was my pleasure. I enjoyed doing this, and it's a labor of love with the community, and that I raised my kids and raised my family, and I appreciate giving the time back to you guys in our community. So thanks again for giving me the opportunity.